Hi, my name is Dani, and today I'm going to show you how you can build a real-time data product using Estuary flow. In this example, we are going to perform real-time add performance calculations with data coming from a PostgreSQL database using change data capture, and on the other side landing in a Snowflake data warehouse. And in the middle, we are going to implement the transformations using derivations with Estuary flow. So let's take a look at how this can be achieved. As I mentioned, our source database is a Postgres database, and we are going to work with two tables. One is called add clicks, and the other one is called add impressions. If I take a look at add impressions first, you can see that it is a table that contains just an itemized list of the impressions of a certain ad. This by itself is not that useful to calculate performance because now, for now, we are interested in clicks. So let's take a look at how the add clicks table looks like. Add clicks. Yeah, similar structure, but this one includes the click level data, which is what we're interested in. So as you can see, I have a data generator script running here in another terminal, which is continuously inserting new impressions and new clicks for a randomized list of ads. So the first step is that we need to get this data into Estuary flow. And to do that, all you have to do is navigate to the Estuary flow dashboard and create a new Postgres capture. And I'm going to do just that right now. So we are going to use the real-time CDC, log-based CDC connector for this. And I will give it the name demo add performance, for example. And let me just quickly copy paste the server address and the password so we can quickly get started and capture data. Once that's done, I'm going to press next, and Estuary flow will validate the connection and give me a list of available tables that are ready to be replicated. As expected, add clicks and add impressions show up in the list of bindings already enabled, which is perfect for me because these are the two tables that I want to replicate. So I'll just go ahead and press next and save and publish, which will provision the connector itself. And as a first step, it will start a backfill process that will get all the existing data currently in the table and save it in Estuary flow, and after that switch into a continuous replication mode using the write-ahead log of the Postgres database. Great, looks like it was successful, so I will click close here, and in just a few seconds we should be able to see data arriving as well. Let me just refresh once. In the right-hand side, you can see the two collections that this capture is writing data into, one called add clicks and one called add impressions. Let me take a look at the add clicks, for example. So it looks like I might just have to wait one more second. And there we go. All right, so now you can see the preview of the data, which shows you how it looks like once it's been ingested into Estuary flow. And we can see that the schema or all the fields that I want to capture are present here, which is great because that's what we want, because these are the fields that we are going to do our real-time transformation on. So in order to do a real-time transformation, as I mentioned, we are going to use derivations. Derivations are Estuary flow's way of defining declarative transformations that result in other collections. So the inputs are collections, and the outputs are also Estuary flow collections. So for our use case, I already have a derivation definition prepared. Essentially what we want to achieve is a third collection that counts the number of clicks for each platform shown that had add impressions. So for this, we will have to join the two data sets first, and then reduce or group the records by platform, and then count the number of occurrences of a click event, essentially. So this is how it looks like defined in a declarative way for Estuary flow, you can see that I create or define a collection here by the name of add clicks by platform. I give it a description in its schema property. Its type is going to be an object, and the properties here is interesting because I essentially want two fields showing up in the results. One is the platform, which is the platform that shows the ad, like the ad impression, and this field comes from the ad impressions table. And the other one is the click count, which is an aggregate field, and this is the number of occurrences of click events. And here I'm going to annotate this field using the reduce property, and I'm going to set the reduction strategy to sum, because essentially we are going to increment the click counter by 1 every time we see an integer, and we are just going to sum these values together. So once the schema is defined of the collection that is going to be the result of the derivation, the next step is to tell Estuary flow how it is going to arrive at that schema. And we can do that here in this section called derive. So if you think about it this way, it means that schema, that collection, is derived using this part below. And here we define a TypeScript function or multiple functions, a TypeScript module that is going to hold the transformation itself. It's going to run two transformations. One is called from impressions and the other one is called from clicks. The from impressions is going to grab the values from the add impressions collection, as you can see here, and the from clicks function is going to grab the values from the add clicks collection. So if I take a look at the TypeScript function itself, this is how the implementation of Z functions look like. Here's the from impression, and here's the from clicks function. So you can see that the from impressions doesn't have any click counts because the impressions table doesn't count as the impression records don't count as add clicks. But here in the add clicks records, we always set the click count to 1, because when a record comes from the add clicks collection, we want it to be counted as a add click. All right, so the next step is to take this YAML file, the YAML definition, and the TypeScript file, and send it over to Estuary flow. So I can do this using flowctl, the command line tool for Estuary flow. Publish the function, the derivation, to Estuary flow. So Estuary flow will create a draft and ask me if I really want to create this derived collection right here. I will tell it yes, and in just a few seconds we should be able to navigate back to our dashboard and see the derived collection live. So publish was successful, great. I can go back to the Estuary flow dashboard, and as I mentioned, derivations also result in collections. So if I go to the collections tab, I should be able to see the demo ad performance add clicks by platform derivation that I just created, which is great. This derivation is going to collect the data from the two source collections and create the add clicks value that we are looking for. As you can see, it already started transforming data. So in order to see the result of this derivation, because we rely on the target database system to reduce the records that are coming in from the source collections, we are going to have to create a materialization for this. All right. And to set up the Snowflake materialization, I'm just very quickly going to press materialize here and select the real-time Snowflake materialization connector, and super quickly just copy paste the credentials. Snowflake, give it a name, and for the database, I'm going to use just the defaults recommended by Estuary. Estuary schema, Estuary warehouse, Estuary role, perfect. And the last one is the Estuary user. I'm gonna go ahead and add the password as well. And as a last configuration step, I'm going to set the sync schedule to 0 seconds for this demo. In some cases, you would want this to be a bit higher just to save on Snowflake costs. It's not always economical to have a warehouse running nonstop. I'm going to press next. And in a few seconds, I will make sure that the collection that I want to materialize into Snowflake is enabled in the bindings list. And I'll just go ahead and press save and publish. And in just a few seconds, similarly to the Postgres connector provisioning, Estuary will spin up the connector and start with a backfill to load all of the records from the derived collection into Snowflake. This is going to take a few seconds until the connector starts up, but if I refresh here, we should already see that the shard is green, which means it's working properly, and I can just head over and go to Snowflake and see if the table that I want to see is already available here. The table is indeed here available, and let's take a look inside to see if the materialization is properly loading the data that we are loading the transform collections. So I'm just going to select the platform and the click count, and as you can see, Facebook ads 182, Google ads 193, and there's some Twitter ads click counts as well. So let's see if I query the table again. Are we going to have different click counts for each? And it looks like the click counts are being generated a bit slow, so we might have to wait a few seconds until the values start to be different. But there we go. As you can see, the click counts are indeed being updated in real time, coming straight from the Postgres database that we configured as the source earlier. Let's run it again just to make sure. Yeah, there we go. Cool. Well, that was it. Thank you so much, and I hope you enjoyed this quick tutorial. And if you have any questions, reach out to us in an email or send us a message on our community Slack, or feel free to reach out to me personally and just send me a message. Thanks so much. Bye.